Hello again everyone, welcome back to ptet.chemistry channel. So this is a tutorial video on Cambridge International O-Level Chemistry. So that is for 14 to 16 years old chemistry curriculum. This is for the 5070 subject called paper 1, variant 2. In fact, there's only one variant paper for the June 2013 series. It's just this one paper. So Cambridge O-Level Chemistry is still taken in a lot of Southeast Asian country and a lot of Asian country, and they're almost equivalent. They align well with the GCSE as well as IGCSE curriculum, and MCQs are very good practice type of questions to assess your theory, because they actually test more than just one theory concept at one time. And if you are very good at your theory, you should have no problems getting 38, 39 or even 40 out of 40, although the chance of getting 40 out of 40 is 2 to the number 2 to the power of 40. There's 2 times 2, 40 times. There's 2 to the power of 40. There's the odds of getting all 40 correct. So you can imagine you can imagine getting all of them correct, yeah. So yeah, let's get started with this question 1. Which mixture could best be separated by using a separating funnel? So a separating funnel is to separate immiscible. Immiscible means do not mix, okay? Do not mix. Things like oil and water, okay? Things like aqueous and organic layer, that is fine because they do not mix, all right? Oil and sand, they do not mix, but because sand is also insoluble in oil, you can be better off doing filtration, although oil is not as free-flowing as water, yeah? But oil and water definitely do not mix. You can definitely use separating funnel. You get 2 layers because they have different density, oil float on water. So you get water coming out first, then you can collect the oil. Sodium chloride and sand, that is filtration, that is the best way. Sodium chloride and water, well, you filter, then you evaporate off the nope, you don't filter, sorry, because sodium chloride is soluble in water. So what you do is you evaporate the H2O, then you can set the sodium chloride to crystallize, and you can filter it, and you get really nice crystals of sodium chloride, pure crystals. Number 2, you want to boil a liquid and then you condense the vapor. That is really just distillation. Because of this part, you need to condense the vapor after you boil it. That is just distillation. Quite an easy start to this paper actually. Okay, so which compound, when you mix it with aqueous barium nitrate, does not give you a white precipitate? Alright, so here you have ammonium carbonate, NH4 plus, CO3 2 minus. The LCM of 1 and 2 is 2, so you need 2 of these and you need 1 of these. Barium nitrate, think about it, the LCM again is 1 and 2, so that means your formula is going to be barium nitrate. That's why you see the formula written as barium nitrate. Barium NO3 twice, this one will be NH4 twice, CO3. What will happen? Well, you will get exchange of cation and anion. You will form ammonium nitrate. You will form barium carbonate. Barium carbonate is insoluble. All of the group 2 carbonates are considered insoluble. So this one will give you white precipitate, which is why this is not what you want. You want does not form a white precipitate. Dilute sulfuric acid, well, you will get barium sulfate because you have the sulfate from sulfuric acid. You add in the Ba2+, it's going to come out as a white precipitate. Barium sulfate is an insoluble white precipitate. You know it from paper 3 practical component. You also know it because identification of cations and anions and gases are all part of the theory paper, which means they can ask you not only in practical but in theory paper as well. Silver nitrate, so you will get barium nitrate and silver nitrate. Well, this is going to be soluble because no precipitate. Silver only give you the precipitate when you have silver halide, like silver chloride, silver bromide, or silver iodide. Here it does not give you any precipitate. But sodium carbonate, again you will produce barium carbonate, and there is a white precipitate. So leaving C as the only one that does not give you a white precipitate at all. Question 4. You have structure of metals. You have positive ions in a sea of delocalized valence electrons. It's actually only the outermost shell electrons that get delocalized. Yeah, it's not all the electrons they have. So what happens to the particles in the metallic heating element of the electric kettle when kettle is switched on? Well, when you turn on the kettle, there must be a complete electrical circuit, right? Otherwise, how would you be heating up? How would you be heating up the water? So there's a complete electrical circuit, and you have current. Okay, so Q is equal to IT in physics. I is current. It's Q over T. So current is defined as the rate of flow of charge, because it's the charge over time is the rate of flow of charge. The charge there refers to the electrons. Okay, so we are talking about electrons being negatively charged. They will move in one direction. The electrons are negatively charged. They will move towards the positive terminal. And which one is the most correct? The electron move in both direction is incorrect. The electrons move in one direction. It's not the positive ions that move, because you get current, which is to do with electron movement. The positive ions stay really. So the electrons move in one direction. So that is correct. The electrons move in one direction. The positive ions do not move. As I mentioned, D was wrong, so positive ions do not move. Therefore, leaving you the answer being B. So moving on to question 5. So they tell you that naturally occurring bromine has a relative atomic mass. This is what you get in your periodic table. This is actually what you call an average mass, but it consists entirely of 2 isotopes. Okay, so you know isotopes have the same proton number but different nucleon number, or different number of neutrons. These both are the same element, so because they are the same element, they have the same proton number, which is proton number 35. I'm looking at the proton number, which is the identity of the element. So proton number for bromine is 35. These are the 2 nucleon number given by the different mass number. Same number of protons, different number of neutrons. Okay, so what can be deduced? What can you deduce? Well, the fact that when you do the average mass, you have around 79 and 81, and you have your average mass to be 80, which is exactly in between. Okay, so your average mass is 80. So to take an average between 79 and 81 and to get it 80 in the middle means that you have about 50% and 50% of each. So it's not like you have more of these or more of this. It's like it's more or less you get about equal proportion of each. Then your average mass is going to be somewhere in the middle. So statement A is actually correct, and it's something you'll explore more in A-level chemistry if you do go on and do A-level chemistry. The bromine there cannot be in different oxidation state because these are element, well, more like the isotope itself, the atom itself, where it's just bromine 0, because you know they are not ions or anything, they're just atom. Bromine isotope have different number of protons is wrong, because like I said, proton number is the identity of the element. You are the same element bromine, so you must have the same proton number. Bromine is radioactive, and that is wrong as well. We use bromine in the lab, and bromine is not radioactive. Okay, radioactive means unstable nucleus, but bromine exists as a liquid at room temperature and pressure, which people could use and could handle. We use it to test for alkene as well, so it's not radioactive at all. Question 6 is about silicon carbide. Silicon carbide has a structure similar to diamond, if you are unaware. So in group 3 and group 4 and group 5, you have boron, carbon, nitrogen. So when you have carbon and carbon, when you have boron and nitrogen, you have 4 electrons, well, 4 outer shell electrons and 4 outer shell electrons. You have 3 outer shell electrons and 5 outer shell electrons. So 4 plus 4 is equal to 8. 3 plus 5 is equal to 8. That's why Bn has a very structure similar to actually carbon and carbon. but rather than following the structure of diamond, they follow the structure of graphite. So boron nitride follow the structure of graphite, but silicon carbide, which silicon below carbon, is in period 3. This is period 2 in the periodic table. Silicon carbide has a structure similar to diamond, and bronze is an alloy, so it's a mixture of metals. So you still have metallic bonding because you are just a mixture. You haven't done any chemical changes. So they're looking for correct statement. All are bonded covalently. That is incorrect. Bronze is still metallic bonding because you still have the copper and the tin metallic bonding. Because you have metallic bonding, so bronze can conduct electricity. Diamond cannot conduct electricity because diamond cannot conduct electricity. So silicon carbide, which has a structure similar to diamond, cannot conduct electricity. But Bn, boron nitride, similar to graphite, which can conduct electricity. So Bn can conduct electricity. All except silicon carbide can conduct electricity. That is correct. All of them will have high melting point. Well, diamond and graphite for sure because they have giant molecular structure. This is an alloy of metals. They have giant metallic structure, which means strong metallic bonding between the positive metal ions and the sea of delocalized valence electron. Strong metallic bond means high melting point for metals. So 2 and 3 only are correct, but not number 1. Number 7, what can you deduce about two gases, same relative molecular mass? So the MR is the same, all right? Can we say they have the same boiling point? Well, when you have N and you have CO, okay, so actually that's how the thing looks like, okay? And then you have MR equal to 28, and this MR equal to 28 as well, because 12 plus 16 is 28. So they have the same molecular mass, but actually they do not have the same boiling point, okay? So it's not really a conclusion, right? So not necessarily the same boiling point because they can also have the same molecular mass, but different atoms actually. So I'm not very happy with A. How about same number of atoms in one molecule? Not really, no. How can I show this? Well, let me just go through option C first. They have the same rate of diffusion at room temperature and pressure. So your temperature doesn't change, but because your molecular mass is the same, your rate of diffusion will be the same. I think based on what we know about diffusion, C is probably the best option without having to worry about B at all. Because when you know rate of diffusion depends on temperature and also molecular masses. Temperature is constant, so looking at the molecular masses, they are constant, so they will have the same rate of diffusion. Solubility in water is difficult to tell as well, just by molecular masses alone. Yeah, so C is definitely the best option there. Question 8, it says sodium is in group 1, so we know it has got 1 outermost shell electrons or 1 valence electron. So when you have sodium combines with chlorine, so sodium is 281 electronic configuration, chlorine is 287, so this would lose 1 electron, this will gain 1 electrons, and it will form chloride and it will form sodium ion. So what happened then is it's not a sharing of electron. What happens to the sodium atom? So we are not looking at what happened to this, we are looking at what happened to this sodium atom. It will lose 1 electron, so it's not gaining 1 electron, so this is wrong. Yeah, sodium loses 1 electron to 1 chlorine atom, okay? And it loses 1 because you just need to lose 1 to get to neon configuration. You just need to gain 1 to get to argon configuration. Okay, so both neon and argon are noble gas configurations, and they are very much favored for their inertness, for their stability in their electronic configuration. Okay. Next bit, hydrogen and sulfur react to form the compound hydrogen sulfide. So hydrogen sulfide is actually H2S. You can think about H2O. So H2S is going to look like H2O. What type of bonding? Well, I've just shown it to you. There is covalent bonding. You can draw the dot and cross, dot cross, hydrogen, hydrogen. Sulfur is in group 16, so do not forget dot and cross. Show all outer shell electrons. Sulfur is in group 16. 1, 2, 3, 4, 5, 6. 6 outer shell electrons, yeah? And because it is simple molecular, you can't conduct in the liquid state at all because you do not have free electrons, you do not have free ions, okay, because you are a simple molecule. So they're just 9b. You don't conduct electricity even when you are solid or liquid or gas because you are a simple molecular structure. Question 10. What do you know about aqueous? So that means in water. That means you have a mixture, okay? So K plus, SO4, 2 minus. The LCM of 1 and 2 means you need 2 of that and you need 1 of it. So the proper formula is K2SO4. Well, there is 2 times K plus and there is 1 time SO4, 2 minus. So there is only 1 sulfate compared to 2 potassium. So that is wrong. And what do you want? You want correct. 2 different type of molecule. 2 different type of molecule. Molecule is not exactly wrong. This is a molecule. This is ionic. So I don't think I want that, okay? It does not conduct electricity is wrong. Well, you have aqueous ionic compound. Okay? Ionic compound in aqueous solution, you have free ions that can conduct electricity. It forms a white precipitate when you add it to barium nitrate. This is aqueous. This is aqueous. What happened then is, well, you get this ionic equation. Barium 2 plus reacts with sulfate. This is your test for sulfate in your, I keep on saying that it's in your practical, but it's actually in your theory as well, yeah? Identification of cation and anion comes under your theory paper as well, which means they can ask you in paper 1 or paper 2 or paper 3, okay? So there's the precipitation reaction. Precipitation reaction. You generate this white precipitate, which of course you done it in practical, I hope, a lot of times, and you know it's insoluble. So there's a correct statement there. Number 11. So they talk about one volume reacting with equal volume of gaseous hydrogen to give you 2 volume of gaseous hydride. So X2 plus H2 give you 2HX. Why do I say 2HX? Because when you have 1 mole of it and 1 mole of it, and when you get 2 volume of something, okay, when the only thing you can get 2 volume of is if you have HX, because if you have something else, then the equation cannot be balanced because there's no other product. There's only 2 of that, so you need 2 of hydrogen and 2 of X, okay, and the 2 is in front already and you can't add any more because it's only 1 and 1 mole of it, so it must be 2HX, so it must be HX as a result of it, and your equation will be balanced that way. 1 times 2, there's 2X. 1 times 2, there's 2 hydrogen. Number 12. What is the mass of 2 moles of chlorine gas? Chlorine gas is Cl2. Okay, so chlorine gas is Cl2. So the molar mass of chlorine is 2 times 35.5 is 71. So that is the mass for 1 gram. Oops, sorry, not 1 mole. 1 mole of CO2. Therefore, 2 mole of CO2 has 2 times 71 gram, which is 142 gram. I hope that makes sense. Number 13, how can you get potassium? This is element. How can you get this element from this potassium chloride? Well, one thing is you can definitely do electrolysis of molten. So that means you have K plus liquid and Cl minus liquid. This can go to the cathode, and you can do reduction at the cathode, red cat, where you gain 1 electrons and you can form potassium metal. So you definitely need method 3. You definitely need method 3. You definitely need method 3. As for between C and D, I just need to check option 2, no need to check option 1 because none of them contain option 1. And also you can compare reactivity series. You know that potassium is a very reactive metal, at the top of the reactivity series. It's more reactive than zinc. Then how can you use a less reactive metal and hope to get the more reactive metal out? Okay, so that doesn't quite work. And I got that by eliminating the options there because I know 3 definitely works. When you electrolyze an aqueous solution, means you have H plus, OH minus, K plus and Cl minus. In terms of the aqueous solution, this is the one that will go to the anode. But that is not what we're interested in. We're interested in between H plus and K plus. H plus will be preferentially discharged. It will be preferentially reduced at the cathode because potassium is such a reactive metal that it doesn't prefer to be reduced. This one prefers to be reduced compared to the K plus, and the only way you can get potassium is if you only have K plus without the H plus being present. So 2 will not give you potassium at the cathode, it will give you hydrogen at the cathode. So only method 3 is correct. I mean, only method 3 can give you the potassium. Number 14. Now you have an aqueous, you also have a concentrated aqueous solution of copper 2 chloride. So the concentration matters because when you have concentrated solution, you can preferentially oxidize the anion of the ionic compound instead of hydroxide. Yeah. So you have Cl minus, which of course you have 2 of them, and then you have H plus and OH minus. So between all these, you're going to preferentially discharge this because you have a concentrated solution. It will actually make more sense when you go to A level because there are a lot more detail that we can tell you at A levels. Much more interesting detail. All right. Between copper 2 plus and H plus, copper 2 plus is below hydrogen in the reactivity series, and therefore copper 2 plus prefer to be reduced. So this is the one that will undergo reduction at the cathode. So you will get copper 2 plus 2 electrons, giving you copper. Reduction is gain of electron. This happens at the cathode. Cations go to the cathode because cathode is negatively charged. You want the positive electrode, which is anode. So what you want is, you want what happens at the anode, which is where oxidation happens. Because you use the concentrated solution, the chloride is going to go to the anode, and you're going to form chlorine, and you're going to lose electrons. You're going to balance your chlorine atom, and you're going to balance the charge with, you're going to balance the charge with 2 electrons as well. Alright, so that is what happened. You will get gaseous chlorine being formed at the anode. Number 15, you have an electrolysis experiment. You use inert electrode. Before electrolysis, you don't have any gas being formed. That's why your water fills up to the max. After electrolysis, you get some gas being formed at a greater volume than the other gas. And roughly, I hope you can see roughly this is 2 volume. This is 1 volume. Take note of this negative terminal. This negative terminal means it is anode. It is cathode because it attracts cation. It attracts cations. Cations are positively charged, whereas this is anode, it attracts anions. What is important to see is that the 2 volume is to 1 volume. It's actually hydrogen and oxygen. When you think about it, the electrolysis of water giving you H2 and O2. 2 of it, then 2 of it. So that's why you get 2 is to 1 because it is the H2 is to the O2. So essentially this question is asking, when you have the electrolyte being one of these, what you're doing is you are doing electrolysis of water, giving you 2 is to 1 hydrogen to oxygen. Alright. When you use inert electrode, so you have copper 2 plus, SO4 2 minus, H plus and OH minus. Copper 2 plus preferentially discharged at the cathode. we are looking for hydrogen, so I don't even have to work out the other one, but the other one is going to be this one. That will give you O2, that will give you copper at the cathode, O2 at the anode. It's not going to give you hydrogen. Okay, so that can't be. When you have concentrated aqueous sodium chloride, what you get is H plus or H minus from the water, Na plus and Cl minus from the corn NaCl. But because you have concentrated, you're going to favor the chloride going to chlorine, the H plus going to H2. That's what you want. That is not what you want. What you want is you want oxygen, because otherwise if it is chlorine, it's not going to be give you 2:1 volume. This is 2:1 volume. So that is not going to be correct as well. Ethanol is simple molecular, so it is not an ionic compound, so you can't electrolyze it. And when you have H2SO4, you have H plus SO4 2 minus. Of course, you have two of it. I've just written one of it to show you what is going on. You could choose any of the H plus to get electrolyzed, but essentially you can, what you're doing is this goes to the cathode and this gives you the hydrogen, this goes to the anode and this gives you the O2, and they will be produced in 2:1 volume ratio. 2:1 volume ratio. The electrolysis of dilute sulfuric acid is essentially the electrolysis of water. So question 16, it's saying that it is a reversible reaction. You have a reversible reaction. So reactant going to product, a reactant going to product. It's telling you that this, whatever they've shown you, is for the forward reaction going from reactant to product. But they want you to think about reverse reaction, right? So reverse reaction means product to reactant. So if I draw a different color, let's choose a slightly different color. Product to reactant, the activation energy is going to be that. So that is the activation energy for reverse, from product to reactant. Product to reactant, so your product will have to gain energy to go from this side to this side. So the sign of the activation energy is still going upward, so it's still positive, but your enthalpy change from the product to the reactant is now upward. So your product has to gain energy to go to the reactant. Your reactant have more energy than your product, that's why it's going upward. That's why the enthalpy change is greater than 0. And we talk about endothermic reaction. This is the enthalpy change of the reverse reaction being greater than 0. Number 17, we are looking for a redox reaction. So first of all, reaction A is a precipitation reaction. It is not a redox reaction because even though oxidation number have been taken out from your syllabus, I hope your teachers would have still done oxidation number with you. You will know that AgCl still has Ag plus and Cl minus. They are still exactly the same. There is no change in oxidation number or the nature of the ion at all. Next bit is a acid carbonate reaction. So acid carbonate reaction is not a redox reaction, and I'll show you in a little bit why. The next bit is a neutralization reaction. As you know, H2O, whenever you do electrolysis, when you have aqueous solution, you always say that, oh, H2O or aqueous, you always have H plus and OH minus, because this equilibrium exists in reality. Okay, so obviously we don't think of water dissociating to ions, but that's why when you do electrolysis, you have to consider H plus and OH minus from the aqueous solution. And this is the H plus and OH minus combining to give you the water. So there's no changes in them at all. Okay, therefore, this is not a redox. Acid carbonate reaction is also not a redox because that is hydrogen plus 1. That is CO3 2 minus. So overall is minus 2 because of the charge. Let's say you want to find the carbon oxidation state. You have 3 oxygen. The oxygen is bonded to something, so the oxidation state is minus 2. So the carbon is minus 2 plus 6 is plus 4. When you have H2O, in H2O, you have the oxygen as minus 2, the hydrogen is plus 1, 2 times plus 1 minus 2, there's no overall oxidation state. 4 CO2, each oxygen is -2, overall is 0 oxidation state, so that's carbon plus 4, no change in oxidation number. So that's why acid carbonate reaction is not a redox reaction. The zinc here, you can think about the zinc forming zinc 2 plus. That is your oxidation, because oxidation is loss of electron. Your copper 2 plus has gained electron to become copper. Reduction is gain of electrons. Your Ulrich mnemonic here. You can think about oxidation number as well. Zinc 0, copper plus 2, zinc plus 2, copper 0. Number 18, you have 4 separate mixtures. In which mixture does the gas form? Well, you have a test for NH4 plus. This is a very common thing in your practical paper. But of course, identification of cation and anions also come out in your theory paper as well. So you do get NH3 being formed, NH4 plus OH minus. You get NH3 plus H2O. This is a classic ionic equation that you'll be expected to write in the theory paper, as well as even in practical paper. Balance equation, balance charge. What is the reaction happening? Test with red litmus paper, it goes blue, basic gas. Sodium hydroxide and acid do not react, so that is true. So in fact, not help there. Acid and ammonium chloride. Acid and ammonium chloride will not give you ammonia gas, alright? Because when you think about ammonium chloride, they can give off NH3 plus HCl. So when you have H2SO4 plus NH4Cl, the H2SO4 can react with the NH3 and you can get NH4 twice SO4, and then you just get back the HCl. So to balance the equation, I can get 2 of it and 2 of it. You don't get any gas, you form another salt. So you don't get any gas, but sulfuric acid and magnesium, you do get a gas, you get a hydrogen gas. Metal, reactive metal plus acid. So even if you don't know that step, you should be able to work out that this is the correct reaction that give you a gas, because this one say it doesn't give a gas. So by elimination, even if you don't know this, you should be able to get a correct answer if you think deep and hard, alright? Question 19. So if I change to a different color, you have 4 oxides, you add them separately to NaOH. So this one is amphoteric, this one is acidic, copper 2 oxide is basic, so most of the metal oxides are basic. This includes like copper 2 oxides, but aluminum oxide and zinc oxides are special, they're amphoteric, so they react with both acids and bases. Yeah? This is reaction with base. So basic oxide will not react with base, acidic oxide will react with base, amphoteric oxide react with both base and acid, so amphoteric oxide will react with base, so 1 and 2 will react with base. Question 20. So you have a system in equilibrium, or that is a dynamic equilibrium. So we need to think about Le Chatelier principle. Don't worry if you have never heard of this before. You would have used it unconsciously without knowing the principle, because whenever you explain how temperature affects equilibrium position or equilibrium yield, or how pressure or concentration affects equilibrium position and equilibrium yield, you talk about how the system will respond in order to oppose the change, in order to counteract the change, in order to go against the change. That is Le Chatelier principle. Okay. I guess like if you're not very strong with this, I suggest you go through the GCSE and O-level topical playlist, cover a little bit of theory, and see how I explain it. It's going to be very, very important, especially if you go on to do A-level chemistry. If you don't master it properly, it's going to cost you big trouble in the long run. Yeah, so make sure you cover your theory, not just for this MCQ paper, but in the long run as well. Especially over the coming break, if there are certain areas that you're very weak in, it's best to be aware of the heavy workload as well as the fast pace of the A-level if you're going to do an A-level chemistry, yeah? So you want to get more chlorine. Chlorine is on the right-hand side, so you want to favor forward reaction. You want to shift the equilibrium to the right. Catalyst is the first thing you can cross out because catalyst only affects rate. It only increases the rate of reaction. It never changes the amount, okay? I guess the other thing you can think about is, let's do concentration first. Your HCl is a reactant. So when you increase HCl, you increase the concentration of HCl, your system or your reaction will try to decrease. It will try to decrease the concentration of HCl. HCl is a reactant. The only way you can decrease your concentration of HCl is to react more HCl. Therefore, favor forward reaction. Therefore, shift equilibrium to the right hand side. Therefore, more CO2. Guess what? We got what we came for. Alright? You can think about the other options being incorrect because you have 4 plus 1. You have 5 moles of gas on the left. You have gas and gas. 2 plus 2 is 4. So the more molecules of gases on the left means this side is exert higher pressure, this side exert lower pressure compared to this side. When you decrease pressure, your equilibrium will try to increase the pressure, oppose the change, counter the change, go against the change. Increase the pressure means it will shift to the side with more gaseous molecules. It will shift to the left, you will get lesser CO2. I guess same deal with temperature. The forward reaction is exothermic. It releases heat. When you increase temperature, your forward reaction will release less heat. By releasing less heat means your equilibrium shift to the left, and therefore you will get lesser CO2. All of these, if it had come out in paper 2 and you weren't able to explain it, that means you don't really know your equilibrium that well, yeah? So equilibrium is one of those things where if you can score very well, it can definitely help you win a lot of marks, yeah? 21. What is the use of sulfuric acid? So we don't use it to manufacture ammonia, obviously. We don't use it to manufacture sulfur trioxide. We use sulfur trioxide to make sulfuric acid. Cl2 is used as a bleach. So sulfuric acid is just used to make fertilizer. Not as fertilizer because it will make your soil acidic, but you use it to make fertilizer. 22. What about ammonia is correct? Well, this first thing, odorless, is not true. If you have smelled ammonia before, it smells, okay? It stinks. It's like the smell of urine, a little bit, okay? It's a gas which turns blue litmus paper red. That is not true. Ammonia is basic, so it will turn red litmus blue, okay? So when you have potassium nitrate with sodium hydroxide and aluminium, so sometimes we call it Devada's alloy. This is your paper 3 practical. It's a test for nitrate ion. So this Devada alloy can reduce the NO3 minus all the way to NH3. Okay, so indeed this is correct about ammonia. You do get ammonia when you heat potassium nitrate. This is not a test for ammonium. This is a test for nitrate ion. Tests for cations, tests for anions, they are all in your theory paper. Okay, whether they're in practical where you're given the data in the table, but in theory paper you're not given those data, so you gotta know what you did here. And of course, this last one is wrong because you use V2O5 for contact process, and contact process is used to make sulfuric acid. 23. Which property is common to calcium, potassium, and sodium? So these are group 2 metal, this is group 1 and this is group 1. Instead of checking all the neutrons and the protons, I reckon we could do better with our time if we check through the rest of the option first. I can tell C is wrong because they said they're all sink, so sodium and potassium float on water, so they're pretty light group 1 metal, yeah? Lithium, sodium, and potassium will float on water. Calcium will sink in water. When you have the molten chloride, so you just have the Cl minus, and then you have the metal cations, which in this case is calcium 2 plus cation, K plus, and sodium plus. And we have reduction. We have reduction at the cathode. Cathode attracts cations. Cations are positively charged, so cathode is negatively charged. So this is wrong. Metals are deposited at the negative electrode, which is the cathode, because you reduce the metals at the cathode. So now I'm left with A and B. Well, let's think about it. The ions, calcium 2 plus. Calcium 2 plus will have the configuration of 288. It has the argon configuration. How about potassium? Potassium will have 288. Oh, same deal, argon. And sodium plus will have 2 and 8. It will have neon. But they are not asking if they have the same number of electrons. They are saying that they all 8 electrons in the outer shell. 8 electrons in the outer shell. So I think we got our answer. So even though they are not the same number of electrons, but all of them have 8 electrons in the outer shell. So B must be correct without me having checked for A. I could check for A, but it's going to take a few more calculations to work out the neutrons and the protons, okay? And of course you can do that if you want to, alright? (24) Solubility of some compounds of metal Q in cold water. In terms of the carbonate being insoluble, you can cross out sodium because Na2CO3 is soluble in water. It's the group 2 carbonate as well as lead 2 carbonates are insoluble. This is soluble, so the chloride is soluble. You can cross out lead because PbCl2, that is Pb2 plus Cl minus, so you need 2 of them, is insoluble in water. All chlorides are soluble except for silver chloride and lead 2 chloride. So both silver chloride and lead 2 chloride are white precipitate, which you did in practical, which come out in theory because everything is in the syllabus. And then you have the sulfate, which is insoluble. So we're looking at barium sulfate, which is insoluble. Magnesium sulfate is sparingly soluble, but barium sulfate is much more insoluble. It's a white PPT. It's a test for sulfate, always out in paper 3, always out in theory paper as well. So therefore we can identify that as barium sulfate. Well, the metal Q is the barium. 25. Which two statements indicate that metal M may have a proton number between 21 and 30? So 21 is actually scandium all the way to zinc. So we are looking at what kind of properties can tell you there are transition elements or transition metals. Okay. So what is characteristic about transition elements and metals? Not necessarily just about any metals, because all metals conduct electricity. So it's very hard if you're just looking at statement 1 that you know they are transition element. It's got to be something special about transition elements. Well, they can form oxides in variable oxidation state. So one thing that you can be aware of is variable or many or different oxidation states. I'm writing something that I don't want anyone to talk about. Oxidation states. Colored sulfate, so those are property of transition metals that will make them characteristic of their position in the periodic table rather than just being any metals, really. So it's got to be 3 and 4. So next up, 26. An atom of which element has the same electronic configuration as the strontium ion? So strontium ion is strontium 2 plus. Strontium 2 plus, so you have beryllium, magnesium, calcium, strontium, barium. So what happens is when you lose 2 electrons from the strontium 2 plus, you are going to have krypton configuration. Look at the periodic table. You lose 2 electrons from strontium, you are going to become krypton configuration, and that's because they are asking for an atom. So they're not asking for any ion or whatever, they're asking for an atom. So there's krypton atom there. They will have the same electronic configuration as strontium 2+, which is strontium ion, after the strontium loses the 2 outer shell electrons. Number 27. Which one is found at the bottom of the blast furnace? Alright. So you don't get iron as a solid, you get molten iron that flows out of the blast furnace. Yeah, so that one is definitely not collected as a solid. So that's why even though it's the extraction of iron, and this is probably the most common choice among students, you got to think about that you're not exactly getting solid iron, not inside the blast furnace. It flows out until it cools down to become a solid. Alright, you don't get the carbon because all the carbon is going to be used as a reducing agent, and when it acts as a reducing agent, itself will be oxidized to become CO2 eventually. You do get calcium silicate, but not calcium carbonate, because if you use calcium carbonate, you will react with the acidic impurity, such as sand, like SiO2, component of sand. It will give you CaSiO3, and it will give you, it will give you CO2. Sorry, we just moved that a little bit there. And then that thing is acidic. I really don't want to move that other thing there. Anyway, so the salt that you get is SiO3 2-. This is the acid. This is the salt that you get. Your calcium 2+ from a group 2, so you need 1 and 1 of it. That's why the formula is CaSiO3. And that's calcium silicate. It also exists as a liquid because of the high temperature of the blast furnace as well. Yeah. So the correct option there would be B. Number 28. So you have gas Z. You separate it from the mixture of gases by this apparatus setup. So the fact that you pass it through copper 2, and then you pass it through aqueous sodium hydroxide. So this aqueous sodium hydroxide is basic. It will remove acidic gas. Alright. For which mixture will this system work successfully? If you have hydrogen and nitrogen will just pass through without, hang on. So you have copper 2. So hydrogen can reduce copper 2 because you have more reactive, and then you have the less reactive metal. So you go from potassium, sodium, blah, 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 hydrogen, copper, silver, gold. So hydrogen prefer to be oxidized, prefer to undergo oxidation more than copper. So hydrogen can reduce copper 2 to copper. So you have copper 2 oxide. So if you have hydrogen, sorry, what is X? You want to separate Z out, okay? So you want to separate Z out. So Z must not react with any of these, okay? So Z must not react with CuO and also NaOH, okay? Because you want to collect Z. So if you have hydrogen, if Z is hydrogen, it won't work because hydrogen can reduce copper 2 to copper. So C cannot be the answer. Carbon monoxide or carbon dioxide, carbon monoxide, that wouldn't work because carbon monoxide is also a reducing agent. So that can potentially reduce the copper 2 as well. So that wouldn't work. What else can we do? Nitrogen and oxygen. Okay. So leaving us down to A and D. So if you have hydrogen and carbon dioxide, that will work because carbon dioxide is acidic. So carbon dioxide is acidic, that thing is basic, they get neutralized, the hydrogen reacts there, so no more hydrogen, and they will leave you nitrogen, which is unreacted, and you can collect nitrogen. So I think we are okay with A, but let me just check this thing here. Carbon dioxide will not act as a reducing agent because it's not carbon monoxide. Nitrogen will not act as a reducing agent, so nothing will be done here. So everything that passes through will be carbon dioxide and nitrogen. Carbon dioxide will react with the base, but the nitrogen will not react with the base, so the nitrogen and the oxygen will be collected. So both of these will not react with copper 2 oxide or sodium hydroxide, meaning to say you will still get a mixture of gases here, and that is not what you want. You want to separate, you want to get Z pure. So that's why D is incorrect. Alright? Moving on, so magnesium can be obtained by heating magnesium oxide with which element? So you want to get magnesium from magnesium 2 plus and O2 minus. You want to reduce magnesium. Okay, you want to reduce magnesium. You need a more reactive metal than magnesium. And in the reactivity series, you have potassium, sodium, calcium, magnesium, blah, 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 blah. There are not many metals that are more reactive than magnesium, one of which is sodium. So that would work. Okay, so sodium is more reactive metal than magnesium. Sodium prefer to lose electron more than magnesium. Sodium prefer to be oxidized more than magnesium. Sodium can reduce magnesium 2 to magnesium 0. Number 30, you have an equilibrium. So they're saying that at 400 degrees Celsius, you get lesser methanol. You get lesser methanol than at 300 degrees Celsius. So temperature increase, lesser methanol. And methanol is on the right hand side. So temperature increase, equilibrium shift to the left hand side, favor backward reaction. This happens because of temperature increasing. So perhaps we should look at what happened with the forward reaction. If the forward reaction is exothermic, it releases heat. Okay. So if the forward reaction release heat, if I increase temperature, the equilibrium want to release less heat because you want to decrease the temperature to go back to equilibrium. That is counteract, that is opposing, that is going against the change. It will try to decrease the temperature by releasing less heat. It will favor to the left, and when you favor to the left, it will favor backward, and therefore it will give you lesser methanol. So I was correct in my hunch in the sense that we should be checking about the forward reaction being exo or endo, and then discussing about temperature effect on the equilibrium position. 31 is about electrolysis of molten aluminum oxide. You have these three following reactions. Which one takes place as positive electrode? Positive electrode attracts negatively charged ions. Because you attract negatively charged ions, you attract anions. If you attract anions, so this is the anion. So this goes to the anode. It doesn't matter, okay? As long as you know it's a positive electrode, it attracts the anion. This is what happened at the anode. Anode. Yep, it attracts anion. So this is the anode. This is the positive electron. So this reaction happened there. But your anode is also made of graphite. And your graphite can react with the oxygen produced. Therefore, you have to replace the anode from time to time because it will get smaller and smaller until eventually it's used up. So 2 and 3 both happen at the anode, at the positive electrode, which attract anions, which are attract negatively charged anion. This is anode. 32, you have an alloy. When you have an alloy, it's a mixture. That means you still have your property of your original metal. So you have copper and zinc, but when you add it to dilute acid in the reactivity series, you have blah blah blah, you have zinc, blah blah blah, hydrogen, copper. So zinc is the more reactive metal than copper. So copper does not react with dilute acid, but zinc react with dilute acid. So copper does not react with dilute acid. That means the copper remains as copper, but you will have zinc 2 plus, and you will have copper still. So at the end of the reaction, your copper is a metal, it's insoluble. This becomes a salt, it becomes soluble. So filtrate Filtrate is the soluble stuff. Is the thing that passes through a filter paper. Residue is the thing that the solid, the thing that you collect on the the thing that you collect on the filter paper. So you will collect copper solid, and you will collect zinc 2 plus, salt. So we are looking at a colorless solution because there's no copper 2 plus, because it does not react with dilute acid. And you will get a red-brown residue, a pinkish residue, sometimes they say. That is basically the copper, which is unreacted. Okay? So question 33 is about the proportion of nitrogen by mass. So essentially we have this molecule, compared to... Well, what are we doing? Oh, sorry. There are just two molecules we're talking about. But this is by mass and this is by mole. Alright? Well, let's work out the MR first. So the MR of CONH2 twice is going to be 12 plus 16 plus 2 times bracket 14 plus 1 times 2. That gives me 60. The MR of this is 14 plus 4 plus 14 plus 16 times 3. That gives me 80. So if I work out CONH2 twice, the percentage of nitrogen by mass, okay, it's going to be 14 for each nitrogen. I have 2 of them, divided by 60 times 100%. That gives me 46.7%. And then for the NH4NO3, I have the percentage by mass of the nitrogen being 14. Again, I have 2 nitrogen, 1 there and 1 there. Make sure you read carefully. That's divided by 80 times 100%. So that gave me 35%. So in terms of percentage by mass, this is higher. So percentage by mass, this one is higher. Okay, so it's not A or D. And I have to think about the proportion of nitrogen by mole. Okay, so now if you look at the formula, in 1 mole of this, the mole of nitrogen atoms, okay, nitrogen atoms. In 1 mole of this, I have 2 mole of nitrogen atom. In 1 mole of it, I have 2 mole of nitrogen atom. This is by mole. Okay, this is also by mole. If I have NH4NO3 by mole to nitrogen atom, in 1 mole of this, I also have 2 nitrogen atom, because 2 nitrogen atom per 1 mole of this thing. I mean 2 mole of nitrogen atom in 1 mole of this. So by mole, the proportion of nitrogen is actually equal. Okay? So there's option B there. Number 34, we want to remove salt from seawater. Removing salt is called desalination. And desalination is achieved by distillation, okay? Because the salt is ionic compound, and the ionic compound will have high melting and boiling point. They won't come off, the water will come off first, all right? So that is a good way of removing the salt from the seawater. Number 35, which compound require the least oxygen for combustion? We are talking about molecular oxygen in the air for 1 mole. So you want to combust only 1 mole of the compound. I guess one of the things we can look for is, well, let's just start balancing equation. So C3H7OH plus O2 give you CO2 plus H2O. You have 3 carbon, so you get 3 carbon there. You have 7 plus 1, you have 8 hydrogen, so you get 4 times 2, you get 4 water. Oxygen, you have 6 oxygen, 3 times 2, you have 4 times 1, so altogether you have 10 oxygen minus 1, so you have 9 oxygen left there. But it's a molecule, so it's 9 over 2, because 9 over 2 times 2. Guess what? The 2 cancel out, so it's just 9. Give you 9 oxygen atom plus 1, 10 oxygen atom, 3 times 2 is 6, 4 times 1 is 4, so 10 oxygen atom. So that is 4.5 oxygen, but there's no way for me to tell which one is the least until I work out for the rest of the molecule. O2 going to CO2 plus H2O. So here is not 3 carbon, here is 3 plus 1, there's 4 carbon. There's 7 plus 1, 8 hydrogen, so I need 4. 4 times 2 is 8, 4 times 1 is 4. Oops, what did I do there? 4 times 2 is 8, 4 times 1 is 4, so 12 hydrogen altogether. 12 hydrogen minus, oxygen. 4 times 2 is 8, 4 times 1 is 4, so I have 12 oxygen minus 2 oxygen, so I have 10 oxygen. 10 oxygen, but I am diatomic, so I need 5 O2. C3H8 plus O2. Remember, I cannot change the number in front because they say 1 mole, so you've got to use the fraction because they say for 1 mole. Okay, so be very careful here. Especially those students or those people who don't really like fractions, you need to read what do they want. 1 mole, 1 mole, 1 mole. 3 CO2, 4 H2O for the same reason as I outlined before. 3 times 2 is 6, plus 4 is 10, so I need 5. And for the last one is C4H8. So CO2 plus H2O, I need 4 CO2, I need 4 H2O. So look at the number of carbon, and then look at the number of hydrogen, and then look at the number of oxygen. 4 times 2 is 8, 8 plus 4 is 12, so I need 6. 6 times 2 is 12. Well, 6, 5, 5, 9 over 2 is actually 4.5. Okay, so that is the least oxygen required. Phew, there was a long one there. Which polymer contains only 3 elements? Only 3 elements. In protein is quite big. Yeah, you have CO and H. You have amide. You have polyamide linkage, and I can cross out A because 1, 2, 3, 4 minimum already 4. Okay, you only want 3 elements. Starch. In starch you have CHO. What else? CH and O. And when you think about polyethylene and polypropylene, they only have carbon and hydrogen, nothing else. They are hydrocarbon because ethene is C2H4, propene is C3H6. These are only 2 elements. You want 3 elements, okay? So it has to be starch. Number 37. So what are the reaction of this compound? So this thing you have the alkene. So you have alkene, but you also have carboxylic acid. Here you have alcohol. So identify functional group is very, very important. Yeah, here you have carboxylic acid, and then both of these is carboxylic acid. Here you have alkene. Here you have alcohols. So decolorized aqueous bromine, we're looking for carbon-carbon double bond chemistry. So there's W and Z. W and Z, so you can cross out A and B. pH less than 7, we are looking for CO2H, carboxylic acid. Alright, so there will be W, X, and Y, because alcohols are not acidic. W, X, and Y. W, X, and Y, W, X, and Y. But we already crossed out A and B, so we only left with C and D, and this one is wrong. There's no need to check the other one already. But of course we can check as well. React with carboxylic acid to form ester, so that means you must have alcohol. You must have alcohol, you must have alcohol, then you can react with carboxylic acid. There's X and Z, X and Z, X and Z. X and Z can form ester on the alcohol bit with carboxylic acid. Question 38. So you have pteryline. Pteryline is a polyester. Hope you can see that is the ester linkage. That is the ester linkage, and there's the ester linkage. So how can you make it? Well, we are going to try hydrolysis. So we're going to try hydrolysis of the ester. When we hydrolyze the ester, we will break this ester bond, the new bond that you form. When you form the ester, we'll break this bond. we will break this bond. This thing there would give you a white color box, and that will give you a carboxylic acid, a white color box carboxylic acid like that. So this gives you the carboxylic acid and carboxylic acid bit. This is the white color box. So the white color box is carboxylic acid and carboxylic acid. It cannot be alcohol, it has to be carboxylic acid and carboxylic acid. It's not alcohol and alcohol, so that's wrong. The white color box is carboxylic acid and carboxylic acid. Okay, now I'm looking at the shaded box. It's this one. So there's OH and there's OH. So remember we crossed out two options already. So now the shaded box is shaded OH and OH. So A is the answer. And this one is not carboxylic acid and carboxylic acid. We're looking for OH and OH. Then you can condense with carboxylic acid on both ends, alright? 39. You want a straight chain hydrocarbon. You want to form a polymer. You want it by addition polymerization. Addition polymerization means you're looking for C double bond C. We're looking for alkene. We're looking for CnH2n, you know, carbon-carbon double bond. This is CnH2n plus 2. When you put in n equal to 6, this is CnH2n. This is our alkene. This is our CnH. Ooh, hang on. Yep, this is CnH2n plus 2 as well. Oh, I thought I saw 16. That's why I was like, hang on a little bit, okay? But 8 times 2 is 16. 16 plus 2 is 18. Same deal with this. This is CnH2n plus 2 when n equal to 9. 9 times 2 is 18 plus 2 is 20. Okay, so this is the only alkene. The rest are what you call saturated hydrocarbon because they are alkane. Saturated hydrocarbon, alkane. Cannot do addition when you have all the carbon-carbon saturated. Yeah. This is the last question of this paper 1 tutorial. We are talking about fermenting. So we have glucose going to glucose going to ethanol, okay, plus CO2. So if I write the proper formula, C6H12O6, you have C2H5OH, then you have CO2, you have, what is this, 2 and 2, 4 carbon, 6 carbon, 10, okay, I think I better use H6O. That's easier on my eye, okay? H12, O2, O4 give you O6, alright? So that is the equation. They always ask this in a theory paper and never say that they never ask you in a MCQ because they could, yeah? So what are you fermenting? You are fermenting carbohydrate, which are like sugars, okay? These reducing sugars. And the gas that you evolve is carbon dioxide, not monoxide. So there it is. So the end of this paper 1 tutorial. So I hope you enjoy it, and please share with your friends, your class group chat, your juniors still in year 9 and 10, your seniors who are doing A-levels, because I've got A-level topical playlist as well, and anyone else you think the videos on my channel might be helpful for. So thank you for watching. And remember to subscribe if you haven't. And I'll see you in the next video.